Hi, my name is Darcy, and I'm here to introduce Lesson 5, Capturing Data from Afar. This lesson is part of the Exploring Venus unit. The guiding question for this lesson is, how can remote sensing help prepare for on-the-ground exploration? This lesson follows the 5E instructional model and includes career connections, local and cultural references, and grade-level differentiation suggestions throughout. Okay, in the Engage section, students will examine satellite images of both Earth and Venus, along with a few local images that you will provide ahead of time. The student's task will be to determine whether each image either shows Earth or Venus, which is a little bit trickier than you might think because Earth can look surprisingly unfamiliar from above. There's also optional follow-up activities that encourage students to dig deeper, exploring what they're seeing and thinking about the scale of the features and connecting those things to things they're more familiar with here on Earth. Okay, in the Explain section, students are going to deepen their understanding of remote sensing concepts and vocabulary. They're going to learn how the placement of instruments, whether they be on a kite, a drone, an aircraft, or a satellite in space, affects what types of images are captured and what kind of science questions can be addressed. The key terms that we'll define include camera resolution, which is the pixel count or image quality that depends on the camera technology itself. Spatial resolution, which is the smallest detail visible in an image, which is determined by both the camera specs and the distance of that camera from the target. And field of view, which is the width and height of an area captured in an image, which is going to change depending on both the camera again and its placement. Students will see how different spatial resolutions and field of views are suited to different types of scientific investigations, and we'll provide some examples from both Earth observing and Venus observing NASA missions. There are math options built into this part of the lesson. For younger students, that means basic multiplication and division. For older or more advanced students, there are options to incorporate trigonometry. Okay, now we get to the really fun part of the lesson, which is the Elaborate section. This year, we've partnered with another NASA science activation team called the AERON Project, which stands for AeroCats and Rover Education Network. They've developed a patented NASA technology that allows students to conduct real remote sensing missions using kites and a payload called an aeropod. Before flying, it's really important to familiarize yourself and your students with the flight operations manual and the safety procedures. There are also helpful videos linked in the lesson that's going to demonstrate the equipment use. And we just want to emphasize that although flying a kite might seem simple, there are safety concerns. So NASA prioritizes safety, and so do we. So this is the part of the lesson where students are going to walk through flight checklist, gear planning, site selection, and even weather forecasting. All of this will build, hopefully, towards a successful flight day. Finally, on the day of the mission, be sure that students bring their flight data sheets, which is in the flight operation manual, because they're going to need those later during the analysis. Okay, back in the classroom, students will review the video footage they captured during their Aeropod flight, and then using tools like VLC Media Player or just a screen grab, they're going to extract still images and begin their analysis, which can include visual observations from the video, image classification, mapping of different terrain types using graph paper and a legend, calculating areas of different terrain types, and then maybe even summarize that information in a bar graph or pie chart. So lots of further analysis. We hope that they will upload their results to the AERON Mission Mapper, which is a GIS-based tool where students can compare their findings with other students and educators across the country. If you do choose to use that tool, we just ask you to not include any personal information in that upload, like students' names or something like that. This part of the lesson includes the final deliverables that are tied to Mission Objective 5, and so those deliverables should be compiled into each team's mission development log. This part of the lesson also includes 3 extension options, including exploring careers related to NASA and remote sensing, the opportunity to observe changes over time by repeating the Aeropod mission, or they can use satellite imagery from sources like Google Earth or NASA Worldview, and we provide some links to help facilitate that. Finally, students and educators can investigate the physics of flight using kites by building small kites and experimenting indoors. And we make some connections to the Wright brothers and how they used kites when they were developing their first airplane. You can see the standards connections. Most of the NGSS connections are related to human impacts on the Earth. This lesson can take up to 8 hours to complete, depending on how many Aeropod flights you conduct and how far you travel to your travel site. To save time, we recommend you skip optional parts like part 2 of the Engage section. You can also choose to only focus on the Aeropod campaign, so that's just the elaborate and evaluate, and skip the earlier activities. Finally, if you don't have an Aeropod, you can still complete most portions of this lesson except for the elaborate section. Students can complete, for example, the evaluate portions using satellite images from NASA or Google Earth instead of images they collect from their own Aeropod campaign. And yes, Aeropods are part of the companion course supply program. If you qualify, you can request them through our webpage. And of course, if you have any questions, please visit our website or email us at info@nessp.org. Thank you so much, and we hope you and your students enjoy this lesson.